On this example, we have a graph, and we want to find some information from the graph. We want to find the intercepts, if there are any. We want to find the domain and range. We want to find the intervals where the function is increasing, decreasing, or constant, and we want to determine whether the function is even, odd, or neither. Let's take these one by one, starting with the intercepts. So intercepts, you can have X-intercepts and Y-intercepts. And an X-intercept is where the graph crosses the X-axis. So this is the X-axis, the horizontal axis, which I'm highlighting. And we're looking for places where the graph either crosses or touches the X-axis. So we can see that the graph touches the X-axis here, crosses the X-axis here, and touches the X-axis here. So these will be our X-intercepts. So we have X-intercepts at -pi, 0, and pi. Now you might be asked to write the X-intercepts in ordered pair form. If you are, you would write those ordered pairs as -pi, 0, 0, 0, and pi 0. You would probably separate them by commas. And then the second type of intercept is a Y-intercept. And a Y-intercept is where the graph crosses or touches the Y-axis. So the Y-axis is this vertical axis, which I'm highlighting. And you can see that the graph crosses the Y-axis at this location, and that is at 0. So 0 in this example is both an X-intercept and a Y-intercept. In ordered pair form, that would be 0, 0. So that's the domain, those are the intercepts of this graph. So let's move on to finding the domain and range. Now the domain is defined to be the set of all x's. So what I'm going to do is I'm going to use my ruler. And I like to hold the ruler vertically. Maybe before we do this, I'm going to erase all these markings. Okay, so with my ruler, I'm holding it vertically to find the domain. And the reason why I'm holding it vertically is because this ruler is marking off x values when you hold it vertically. And remember, with domain, we're looking for the x values of this graph. So by holding it vertically, I'm paying attention to where the vertical line touches the graph. And if it's touching the graph, that means I have an x value. I have a part of the domain. So if it's touching the graph, that's an x value that's part of the domain. So let me erase these markings. And what I like to do is I'd like to hold it vertically and go from left to right across the graph. And what I want to pay attention to is the first time that my ruler, you might want to use a pencil, I want to pay attention to the first time that that vertical line hits the graph, and then pay attention to the last time that that vertical line hits the graph. And then you can use that, you can use those values in interval notation. So the domain starts at -pi and ends at pi. And all the numbers in between are part of the domain, so we're using our interval notation to mark that. Now, as we look closer at these points, these endpoints are open circles. Not open, they're closed, they're filled in circles. So that means that the endpoints are part of the domain. And that we're going to use brackets to indicate that. So brackets means those values are included. So our domain of this graph is from -pi to pi. So then we're going to rotate this ruler and hold it horizontally. And hopefully you see where I'm going, because the definition of the range are the y values, all of the y values on this graph. So I'm holding this ruler horizontally because if I hold it horizontally, it's marking out the y values along the y scale. And that's what I'm interested in when I'm looking for the range. So I'm going to hold this ruler horizontally. You can use a pencil. And we're going to go from bottom to top. And as we go from bottom to top, we're going to mark off the first time that my ruler hits the graph. So this is the first time it hits the graph. And then I'm going to mark off the last time it hits the graph, which is right here. And pay attention to what those y values are. So we have a y value of -7 and a y value of +7. And that's what I'm going to use for my interval notation for the range. My range will start at -7 and end at +7. Since these points are filled in circles or closed circles, I'm going to include -7 and +7 in the range. To include, we use brackets. So we have a range of -7 to +7. Okay, so I can see some of my markings over here are a little bit off screen, so I'm just going to put in here, I labeled this as domain, and I labeled this as range. So on the next part, part C, this is asking for intervals on which the function is increasing, decreasing, or constant. So these vocabulary words are referring to y, or trying to describe y. Each one of them is describing y. So what I want to do is I want to trace the graph starting from left to right, and that's starting from smallest to largest. So this is the leftmost portion of the graph. And I'm going to start tracing it, as I said, from left to right. And as I'm tracing it, I'm paying attention to the y values and whether the y values are increasing, decreasing, or constant. Now, as I'm tracing along this first section, I can see that the y values are decreasing. And then I get to this point here, and then the y values are increasing. And they continue to increase. The y values are increasing until we get to this point here. And then the y values are now decreasing. So I've found a few intervals of increasing and decreasing for this function. So I'm going to label them. So we said that this section right here, the y values are decreasing, and then also along this section here they were decreasing. And then we said along this section in the middle that the y values were increasing. So let's label that with decreasing, increasing, and decreasing. So now that I have it labeled, I'm going to pay attention to the intervals where the function is increasing, decreasing, or constant. Now these intervals are X intervals. So I'm going to bring out my ruler again, and since I'm looking for X intervals, I'm going to hold this ruler vertically, and I'm going to pay attention to this decreasing section, and I notice that the first time my ruler hits this decreasing section is here. I'm still hitting it, and then the last time it hits that decreasing section is here, which is right here. So I'm going to say that this function is decreasing from negative pi, let me give myself a little bit more room. It is decreasing from negative pi to negative pi over 2. So then we're writing our interval notation, and we need to decide whether we're going to include the endpoints or not. And this is sort of a debatable topic, and it's based upon how your book defines increasing, decreasing, and constant. I teach out of 2 different books, and they have 2 different definitions. One of them allows for the endpoints to be included, and the other one doesn't allow for the endpoint to be included. So you need to pay attention to whatever definition is used in your book to decide whether you're going to put parentheses or brackets on these endpoints. So in my college algebra class, we would put parentheses, but in my pre-calculus class, we put brackets to include the endpoints. So these are the intervals of decreasing. We have one more interval of decreasing over here. It's going to start at this spot right here and end at this spot right here. So that interval of decreasing is starting at pi over 2 and ending at pi. And then we want to mark out this interval for increasing. It starts at negative pi over 2 and ends at pi over 2. So we have an interval of increasing that starts at negative pi over 2 and ends at pi over 2. So we have one more part to go, part D. And we want to decide whether this graph is even, odd, or neither. So we need to know what those mean. An even function is a function that has y-axis symmetry. An odd function is a function with origin symmetry. And then neither is the category that catches everything else. So let's figure out what y-axis symmetry and origin symmetry look like. So let me kind of go in the middle here. For y-axis symmetry, what you would look at is this vertical axis, that's the y-axis. And if you have y-axis symmetry, you're going to have a mirror image on either side of the y-axis. So if I erase the markings that we see on this graph and just pay attention to the line, I'm going to look at the y-axis, and I'm going to look to the left and also to the right of the y-axis to see if there's a mirror image. And I can see that there's not a mirror image here. So in my mind, what I'm doing is I'm taking this piece of the graph and I'm imagining this graph as a piece of paper, and I'm going to fold that piece of paper along this y-axis. And if I were to fold this piece of paper, what I would get is a line that matches over here, but it does not match on top of the other part of this line. So we don't have y-axis symmetry, and so we can say that this is not an even function. So the other type of symmetry is origin symmetry. Let's take a look at what origin symmetry would be like. So I'm drawing the axes, and the x-axis and the y-axis cross at this point, which we call the origin. And when you have origin symmetry, you would have a graph that has a mirror image in the opposite quadrant. So I've just highlighted quadrants 1 and 3. And if you have origin symmetry, those would be mirrored. And then you would also have a mirror image in quadrants 2 and 4. So origin symmetry has a mirror image over the origin or in opposite quadrants. So taking a look at our example, the origin is right here where the x and y axis cross each other. And I'm looking in opposite quadrants to see if there's a mirror image. And it looks like to me there is a mirror image. I can see that in quadrant 1, I have a mirror in quadrant 3. And then in quadrant 2, we have a blank, meaning that there's no piece of the graph in that quadrant. And we also have blank in quadrant 4. So it looks like a mirror image, but if we want to be certain, we can think about folding the pieces of paper like we were doing earlier with the y-axis symmetry. And let me explain how you would fold the piece of paper to check for origin symmetry. So checking for origin symmetry, what you're going to do So if you're checking by imagining folding paper for origin symmetry, what you would do is fold twice. You're going to fold once over the x-axis and then fold over the y-axis. So I'm going to imagine this piece of the graph being folded over the x-axis, and you would get something that looks like this. And then if you imagine folding that new piece over the y-axis, it would fall right on top of the other portion of the graph. So we do have origin symmetry, and we can say that this function is an odd function. Thank you for checking out my videos. Have a great day.